Welcome to Module 4, Types of Pipes and Fittings. Now listen carefully, because this module is where your journey moves from general knowledge to real mastery of plumbing materials. You see, any plumber can install a pipe, but a skilled professional knows which pipe to use, where to use it, and how to connect it right based on pressure, temperature, environment, and function. Water supply, drainage, gas lines, they all demand different materials, fittings, and joining methods. This module will train your eye to recognize pipe types, your mind to select wisely, and your hands to measure, cut, and join with precision. Because in this trade, the pipe you choose and the way you fit it could mean the difference between a solid system and a leaking nightmare. Let's begin.
By the end of this module, you'll no longer guess what pipe to use. You'll know it with confidence. You'll be able to identify the different types of pipes and fittings used in plumbing, PVC, GI, copper, PPR, and understand their specific applications. You'll learn how to measure, cut, and prepare each type of pipe for installation, and most importantly, how to join them using the correct method. From solvent welding to heat fusion, from threading to soldering, you'll gain the hands-on understanding to make leak-free, professional-grade connections. This isn't about memorizing names. It's about mastering materials and knowing how to make the right choices on any site, under any condition. Because the mark of a true plumber isn't just in the tools they use, it's in the materials they understand and the systems they build to last. Let me ask you a question. Have you ever turned on a tap and water flowed instantly? Or flushed a toilet and the waste disappeared without a second thought? That quiet system, hidden behind walls and under floors, is powered by pipes. In plumbing, pipes are lifelines. They move clean water to people and wastewater away from them. They protect health, preserve hygiene, and provide comfort, without being seen, without being celebrated. Water supply. Every time a child drinks from a kitchen sink or a nurse washes hands in a hospital, it's a water supply pipe doing its job. Strong, reliable, leak-proof. Drainage and sewage. On the other side, drainage pipes carry used water from sinks, toilets, and showers out of buildings safely, so disease doesn't spread and environments stay clean. Gas piping. And in homes that use gas for cooking or heating, pipes carry something even more sensitive: flammable gas. That means one wrong material, one faulty connection, and the risk is life-threatening. So you see, this isn't just about connecting tubes. This is about building trust into walls, safety into kitchens, dignity into homes. This is why you must know what pipes are used for, and choose the right type every time. Every pipe tells a story about where it should be, how it should perform, and what it can handle. Let me introduce you to the 4 most common pipe materials in the trade, the ones you'll touch, cut, and install again and again. PVC, polyvinyl chloride, lightweight, affordable, easy to cut. PVC is your go-to pipe for cold water supply and drainage systems. But be warned, it can't handle heat. Use it for hot water, and it warps. It breaks, and your client calls you back, angry. GI, galvanized iron. This pipe is old-school strong, coated to resist rust. It was once the king of plumbing. But today, it's being replaced. It's heavy, tough to thread, and rusts inside over time. Still, on the right job, under the right conditions, GI can be a warrior. Copper. Elegant and durable, resistant to corrosion. Copper pipes are the gold standard, especially for hot water and clean drinking lines. But know this, copper is expensive, and it demands soldering skills. You don't install copper casually. You install it with care. PPR. Polypropylene. Random copolymer. This modern green pipe is built for pressure. It's ideal for hot and cold water supply, especially in residential and commercial buildings. PPR requires heat fusion. You melt it to join it. When done right, the joint is as strong as the pipe itself. Each of these pipes is a tool, and every tool must match its task. Use them wrong, and you fail the system. Use them right, and the system serves for years. So start learning the feel, the weight, the strength, the purpose. Because a true plumber knows, it's not just what you install, it's what you choose to install. Let me introduce you to one of the most common pipes you'll ever handle, PVC, short for polyvinyl chloride. If you walk into a hardware store or a job site, this is the pipe you'll see in stacks, lightweight, white, and ready to serve. Why it's popular. PVC is a favorite because it's light to carry, easy to cut, resistant to rust and corrosion. That makes it perfect for cold water supply systems, drainage systems, and even underground lines. Limitations. But don't let its simplicity fool you. PVC has limits. It can't handle heat. Install it in a hot water system and it will warp, bend, or burst. And because it's plastic, it's not as strong as GI or copper under physical stress. So avoid using it where the pipe might be stepped on, hit, or exposed to harsh environments. How to work with it. PVC is joined using solvent cement, a chemical bonding method. It's quick, but you need to be precise. A rushed or uneven joint could leak later. Field tip from experience. I've seen young plumbers press fittings too hard, thinking tighter is better. But PVC fittings need smooth application, not force. It's about finesse, not strength. Mastering PVC is step 1 in your pipe journey. Respect it, handle it well, and it will serve, leak-free, silent, and strong, for years. Let me introduce you to one of the most common pipes you'll ever handle, PVC, short for polyvinyl chloride. If you walk into a hardware store or a job site, this is the pipe you'll see in stacks, lightweight, white, and ready to serve. Why it's popular. PVC is a favorite because it's light to carry, easy to cut, resistant to rust and corrosion. That makes it perfect for cold water supply systems, drainage systems, and even underground lines. Limitations. But don't let its simplicity fool you. PVC has limits. It can't handle heat. Install it in a hot water system and it will warp, bend, or burst. And because it's plastic, it's not as strong as GI or copper under physical stress. So avoid using it where the pipe might be stepped on, hit, or exposed to harsh environments. How to work with it. PVC is joined using solvent cement, a chemical bonding method. It's quick, but you need to be precise. A rushed or uneven joint could leak later. Field tip from experience. I've seen young plumbers press fittings too hard, thinking tighter is better. But PVC fittings need smooth application, not force. It's about finesse, not strength. Mastering PVC is step 1 in your pipe journey. Respect it, handle it well, and it will serve, leak-free, silent, and strong, for years. Ah, yes, copper. If plumbing had a luxury brand, this would be it. Lightweight, durable, naturally resistant to corrosion. Copper pipes have stood the test of time, and when installed correctly, they can last 50 years or more. Where copper shines. Copper is ideal for hot and cold water supply, clean drinking water systems, high-pressure indoor installations. Because copper can withstand heat and pressure, it's the go-to choice when you want performance, hygiene, and longevity. The catch? It demands skill. Copper isn't plug-and-play like PVC. It must be cut with care, cleaned thoroughly, and joined using soldering. That means heat, flux, and a steady hand. Rush it, and the joint leaks. Overheat it, and the pipe weakens. And yes, it's costly. Copper is expensive. That's why it's mostly used in high-spec projects, hospitals, or where water purity and long life are essential. Pro tip from the field. Always clean both the pipe and fitting with emery cloth before soldering. A dirty joint will fail, no matter how much heat you use. Copper isn't just about piping. It's about craftsmanship. If you can work with copper, you've earned respect. So learn it. Master the flame. Build with confidence. Because copper doesn't forgive shortcuts, but it rewards precision. Now we enter the world of modern plumbing, and right at the center is the green pipe, PPR. Polypropylene random copolymer. Sounds technical, and it is. But this pipe is changing the game across homes, hotels, hospitals, and high-rise buildings. Where PPR excels. PPR pipes are used for hot and cold water supply systems, pressurized pipelines, commercial and industrial plumbing. They handle high pressure and temperature, and they're resistant to corrosion, chemicals, and scaling. That's why they're perfect for complex building installations. But here's the catch. It's heat fusion only. You don't glue PPR, you don't thread it, you fuse it. With a heat fusion machine, you melt both the pipe and the fitting, then press them together. Once joined, they become one solid piece. No glue, no threads, no weak points. But you must get the timing right. Too hot, you deform the pipe. Too cold, the joint is weak. Too slow, the ends won't fuse properly. This isn't a pipe you can rush. You need focus, practice, and discipline. Pro tip from the field. Always check the fusion temperature setting, usually around 260 degrees 6. Clean the pipe, heat it evenly, and press straight. No twisting. PPR is the future. If you want to work in modern installations, you must master this pipe. It demands accuracy and rewards it with performance. So learn to fuse with precision, handle it like a pro, and build systems that last for decades. If you want your installations to fit perfectly, your measurements must be exact. In plumbing, we measure pipes using two main references: the outside diameter, OD, the distance from edge to edge across the pipe's outside, and the nominal bore, NB, a rough reference to the internal diameter, ID, or the space water flows through. Why it matters. You might hear someone say, this is a 20mm pipe. But is that the OD, the ID, or just a label? If you don't know, you could buy the wrong fittings. Or worse, make cuts that don't match anything. Most plastic pipes, like PVC and PPR, are measured by outside diameter. Most metal pipes, like GI and copper, often use nominal bore, which refers to approximate inside diameter. Practical tip. Always carry a vernier caliper, or use your tape measure carefully. Check what standard the pipe follows, metric or imperial, and always confirm before cutting. Two pipes may look the same, but their internal diameter or wall thickness could be completely different. And trust me, mismatched measurements create bad joins, leaks, and frustrated clients. So don't measure with your eyes. Use your tools. Take your time. Because the plumber who knows how a pipe is measured is the plumber whose work fits. The first time. Every time. Now let's get specific, because not all pipes are created equal. When it comes to performance, size matters. Each pipe size has a role to play in the plumbing system, and your ability to choose the right one is what makes you a professional. 15mm, 20mm pipes. These are your everyday domestic lines, used for wash basins, kitchen sinks, toilets, and internal plumbing systems. They're narrow, efficient, and perfect for low-demand fixtures. 25mm, 32mm pipes. These handle greater pressure and volume, making them suitable for overhead tanks and main supply lines feeding entire households. 40mm, 50mm pipes. Used for bathtubs, showers, and washing machine outlets, these pipes are wide enough to handle bulk water drainage, fast and clean. 75mm, 110mm pipes. These are your big boys, designed for soil pipes, waste lines, and underground drainage. They handle solids, wastewater, and high flow rates without backing up. The right size pipe does more than just fit. It ensures function, flow, and longevity. So don't guess. Learn the sizes, understand the purpose, and make the right choice. Every single time. Let's make one thing clear. A pipe can carry water, but it's the fittings that shape the journey. Pipe fittings are the connectors, the changers, the adjusters. Without them, a plumbing system is just a pile of tubes. So what are fittings really? They're components that allow you to change direction, like when a pipe needs to turn a corner, connect or extend pipes, when one isn't long enough, branch off, to feed multiple fixtures from one line, reduce or increase size, when you're connecting pipes of different diameters, seal or close a line, for testing or shutdown. Every fitting serves a purpose, and every job needs the right one. Use the wrong fitting, and the pressure's off. The flow suffers, the system leaks. So start learning to recognize fittings like familiar tools. Because once you understand fittings, you don't just build plumbing. You design systems that last. Let's make one thing clear. A pipe can carry water, but it's the fittings that shape the journey. Pipe fittings are the connectors, the changers, the adjusters. Without them, a plumbing system is just a pile of tubes. So what are fittings really? They're components that allow you to change direction, like when a pipe needs to turn a corner. Connect or extend pipes when one isn't long enough. Branch off to feed multiple fixtures from one line. Reduce or increase size when you're connecting pipes of different diameters. Seal or close a line for testing or shutdown. Every fitting serves a purpose, and every job needs the right one. Use the wrong fitting, and the pressure's off. The flow suffers, the system leaks. So start learning to recognize fittings like familiar tools. Because once you understand fittings, you don't just build plumbing, you design systems that last. In plumbing, a few millimeters can make the difference between a perfect fit and a frustrating do-over. Measuring pipes correctly is not just the first step. It's the step that defines every joint, every connection, and every flow. Step 1. Use the right tool. Don't guess. Don't eyeball it. Use a tape measure for length or a vernier caliper for diameter. These tools tell the truth. Your eyes don't. Step 2. Measure from the right end. Always start from a clean, square-cut end. If the end is rough or jagged, your measurement will be off. And make sure you're on the correct scale, metric or imperial. Mixing them up is a costly mistake. Step 3. Mark. Clearly and accurately. Use a marker or pencil to make your line. Wrap it around the pipe for a full guide, especially for larger pipes where straightness matters. Step 4. Account for fitting allowance. This is where many beginners mess up. When inserting a pipe into a fitting, a portion of the pipe goes inside. Always subtract the fitting depth from your cut length, or your pipe will be too long and won't seat properly. Here is an advice from a mentor from the field. Measure twice, mark once. Always check again before you cut, because once you cut a pipe too short, there's no undoing it. Accuracy is your reputation, and precision is the habit of every master plumber. Start measuring like a pro, every time. All right, now it's time to learn how to make a strong, leak-free joint using the PVC solvent cement method. This method is fast, effective, and easy to master, but only when you follow the steps with care and precision. Step 1. Clean and dry the pipe ends. Start by making sure both the pipe and fitting are clean and dry. Use a clean cloth to wipe away dirt, dust, and moisture, because even a little grit can weaken the bond. Step 2. Mark the insertion depth. Insert the pipe into the fitting without cement, and mark the point where it fully enters. That's your guide for applying cement, and for ensuring you push it in all the way later. Step 3. Apply primer, if required. Some projects require primer before cement. It softens the plastic and improves bonding. If your standard says so, don't skip it. Step 4. Apply solvent cement evenly. Now apply solvent cement to both the outside of the pipe and the inside of the fitting. Use a clean applicator and work quickly. The cement starts setting fast. Step 5. Insert and twist. Immediately push the pipe into the fitting firmly with a slight twist, about a quarter turn. This spreads the cement evenly and creates a tight seal. Step 6. Hold and wipe. Hold the joint in place for 30 seconds. Don't move it. Then wipe off the excess cement with a cloth. Movement at this stage is the #1 cause of weak joints. Step 7. Allow time to cure. Let the joint cure, usually 15 to 30 minutes before handling, and up to 24 hours before pressure testing. This isn't glue, it's chemistry. Done right, this bond is permanent and watertight. So don't rush. Respect the process, and build a joint that lasts as long as the pipe itself. You've now seen how to join PVC pipes, but remember, not all pipes are joined the same way. Different materials demand different techniques. Let me show you the standard joining methods, based on the pipe material. PVC pipes, solvent cement method. Quick, reliable, and widely used. Apply cement to both the pipe and fitting. Push, twist slightly, and hold. It chemically fuses into a single watertight joint. GI pipes, threading or welding. Galvanized iron pipes are usually joined using threads. Male to female connections with sealant or tape. For permanent setups, welding is used, but that requires skill and equipment. Copper pipes, soldering, capillary method. With copper, it's all about heat. You clean both ends, apply flux, heat the joint, and feed in solder. It flows into the gap and solidifies to create a durable, leak-free seal. PPR pipes, heat fusion method. PPR requires a special tool that heats both pipe and fitting. You push them together while hot, and when it cools, they're molecularly bonded. No leaks, no weak points. But timing is everything. So here's what you must always remember. Know your material. Know the right method. Never mix and match techniques, because the joint is where systems succeed or fail. And a plumber who understands joining methods, that's someone ready for the real world. Measure, cut, join. You'll be working with PVC pipes and fittings to perform 3 essential tasks. 1. Measure and mark pipe lengths accurately using your tape or caliper. 2. Cut each piece using a suitable cutting tool, hacksaw or PVC cutter. 3. Join the pipes using the solvent cement method. Follow every step, clean, apply, push, twist, and hold. What your instructor will look for. Proper use of tools and safety gear. Clean, square cuts with no burrs. Accurate cement application. Strong, aligned joints with no visible gaps. Don't rush. Take pride in every move. This isn't just a task, it's a rehearsal for the real world. And what you practice here will show up on every job site you step onto. Now go ahead. Measure carefully. Cut confidently. Join with precision. You've just completed Module 4. And believe me, this one lays the foundation for everything else to come. Let's take a moment to lock in the big lessons. You now know the major types of pipes: PVC, GI, copper, PPR, each with its own strength, purpose, and joining method. And now you know when to use what, not just by name, but by performance. You've learned how to measure and cut with precision, not just for fit, but for flow, safety, and long-term durability. Measurements matter. You've been introduced to fittings and joints, from elbows and T's to reducers and caps, and the joining methods that hold it all together. Because plumbing isn't just about connections, it's about integrity.
Well done, apprentice. You've just completed Module 4, one of the most essential modules in your plumbing journey. But remember, your learning doesn't end with slides. Go back to your training manual, study every diagram, read every step again. Because mastery is built through repetition and reflection. Head to the workshop, pick up those pipes, cut them, join them. You've seen how it's done, now it's your turn to do it. Under supervision, yes, but with your own hands. And don't forget your module quiz. It's not just a test, it's a checkpoint. It tells you what you've truly understood, and what needs more work. Every pipe you measure, every joint you make, every question you answer, it all counts. Push forward, keep practicing, and I'll see you in Module 5, ready for more.